Welcome back to our Built Better series. In today's episode, we're talking about framing for strength. The frame of a home is like its skeleton, and just like your body, your home can only be as strong as its skeleton. Many homes today are framed to just meet code using standard techniques. But remember, building to code is only the minimum. It's something we have to consider, but not where we should stop if we truly want a durable home. In this episode, we'll show you what separates smart or advanced framing from standard framing. We'll cover why layout matters and how advanced framing can make your walls both stronger and more energy efficient. And lastly, why proper uplift resistance can mean the difference between keeping your roof on or losing it in the next storm. If you're planning to build, these are details you'll want to ask your builder about, because this is where a home becomes built better. Let's start with the basics, the layout. As we spoke about in episode 2, a well-designed and engineered structure carries the load from the roof all the way down to the foundation. Loads are transferred in the most direct way possible, which means less stress on the framing and fewer chances for problems over time. These layouts are especially important in multi-story homes. The way loads move through the floor framing is critical. Aligned versus unaligned stud patterns determine how those loads transfer and what kind of connections are required between the floor plates, floor framing, and the walls below. Being intentional and detailed with layouts also improves buildability for every trade on the job. When walls are placed in common increments, it takes the guesswork out of construction and helps reduce waste. That's why we strive to have all major wall dimensions end in whole numbers and, where possible, in 3-inch intervals. But why do these layout decisions matter? When framing is scattered or misaligned, loads can shift unpredictably. Over time, that leads to drywall cracks, uneven floors, and even structural weakness or damage. A clean, well-designed, and engineered layout not only creates a stronger structure, it also makes finishes come out better. Drywall lays flatter, trim and cabinets align more precisely, and corners are tighter. A smart layout means more strength, better buildability, and a straighter, longer-lasting home right from the start. Now let's take it a step further and look at advanced framing techniques. Traditional framing often uses more lumber than necessary. Extra studs in corners, oversized headers, and spacing that doesn't always make sense. While that approach meets code, it doesn't optimize for strength, efficiency, or energy performance. Advanced framing is about placing lumber where it actually does the work. For example, using 24-inch stud spacing instead of 16-inch can reduce the number of studs in a home by hundreds. On a 2,000 square foot house, that might save 250 to 500 board feet of lumber. While paired with the right sheathing and nailing techniques, it maintains the same structural strength. In addition, fewer studs means less thermal bridging, which allows more insulation in the wall cavity. Studies show this can improve wall performance by up to 30% compared to conventional framing. Another example is utilizing what we call the California corner. Instead of boxing in corners with 3 or 4 studs, we can adjust the configuration to create an insulation cavity while still maintaining the same structural strength. This eliminates cold, uninsulated spots and reduces wasted lumber. Partition walls are another area where advanced framing makes a difference. Rather than running full studs where the walls intersect, using ladder blocking provides the needed nailing surface while leaving space for insulation. And then there are headers. In many homes, you'll see double 2x12 headers over every window and door, even in non-load-bearing walls. Advanced framing sizes headers to the actual structural loads that are required. That means single-ply or smaller-sized headers where possible, allowing again for more insulation above windows and doors and less wasted lumber. The end result is a structure that is just as strong, if not stronger, while using fewer materials, reducing thermal bridging, and improving the home's overall energy efficiency. That's the real benefit of advanced framing. Smarter, not just more. The last piece of framing for strength is uplift resistance. When we think about wind, most people picture walls being pushed sideways. But in a major storm, wind doesn't just push, it also creates suction. That uplift can actually push the roof right off the house if the connections aren't designed to resist it. To counter this, we build with a continuous load path that transfers those uplift forces from the roof, through the walls, and all the way down to the foundation. And like we said, this system acts like a chain. But that chain is only as strong as its weakest link. If one connection fails, the entire system is compromised. Take roof rafters, for example. If they're only secured with toenails, they might resist 150 to 200 pounds of uplift. But with a simple hurricane tie or strap, that resistance jumps to 400, even 1,000 pounds, depending upon the connector. The cost difference is just a few dollars per connection, but it can mean the difference between a roof that holds and one that's gone during a storm. The same principle applies to wall sheathing. Using proper nailing patterns, like 6-inch on center at edges and 12 inches in the field, can increase the strength of the roof or wall diaphragm by as much as 30 to 40% compared to a sloppy or minimum pattern. And that's not just the nailing that matters. The sheathing itself plays a critical role. Structural OSB panels, when nailed correctly, create a rigid diaphragm that locks the frame together. Some alternative products don't provide the same structural performance, or they rely too heavily on adhesives instead of fasteners. That difference matters in high winds, especially where seams and connections are often the first points of failure. This is also why programs like Fortified require documented, tested connections from the rafter to the top plate, and from the studs to the seal plate, and from the seal plates all the way into the foundation. Every link in that chain matters. The bottom line is, uplift resistance isn't about extra hardware for show. It's about making sure that the next big storm, the structure stays tied together as one system. Roof, walls, and foundation all working as one unit. So to bring it all together, framing for strength isn't just about meeting code, it's about building smarter. With intentional layouts, advanced framing techniques, and a continuous uplift load path, you get a home that's stronger, straighter, more efficient, and ultimately more resilient in the face of storms. But this is just one part of the bigger picture of building better. In our next episode, we're going to dive into what Fortified actually means. We'll cover what the program is, how it works, and why it's one of the best frameworks for building a home that truly lasts. Thanks for watching. This is Built Better.